Good morning, my dear students. I am Gopal Rao, working as a lecturer in EC department at Government Polytechnic College, Sangareddy. Today's topic is explain the formation of PN junction diode. So, coming to the topic, today's topic is explain the formation of PN junction diode. Now, see the figure. Shows a semiconductor consisting of a PN junction which has been just formed. It may be noted that this entire sample is a single crystal. Total entire sample is a single crystal. Its left side is P type and right side half is N type. A single crystal, its left side half is a P type and the right half is N type. The P region has holes. P region has holes as a majority carriers. So P region has a majority charge carriers or holes, and negatively charged impurity atoms called negative ions or acceptor ions. The N region has free electrons. P region has majority charge carriers or holes. Here the N region has free electrons. Free electron means majority charge carriers of N side is free electrons. So simply you can say as majority charge carriers in N region has electrons, and positively charged impurities atoms called positive ion or donor ion. Positively charged impurity atoms called positive ions or donor ions. So complete the above figure consists of a single crystal. It is split into two parts. Left side half part is P region and second half, the right side half part is N region. Simply you can say left side half is P type semiconductor and right side half you can say it is N type semiconductor. Coming to the P type semiconductor has majority charge carriers or holes, and coming to the N type semiconductor has electrons majority charge carriers, and the P type semiconductor has charge carriers or the charge is positive. Coming to N type semiconductor, the charge is negative. Negative charges are more in N type semiconductor. The minority carriers in the P and N regions are not shown because just for simplicity the minority carriers in the P and N regions. Now P and N region has majority charge carriers and it's denoted by like shown in figure, and so for simplicity purpose we don't shown in figure as P and N regions minority charge carriers. The holes and electrons are mobile charges. Only holes and electrons are mobile charge and therefore are known as mobile charge carriers. On the other hand, positive and negative ions are immobile charges Ions are immobile charges. Holes and electrons are mobile charges, and therefore do not take part in the conduction. Positive and negative ions are immobile charges and therefore do not take part in the conduction. So ions is nothing but a immobile charges. Immobile charges do not take any part in the conduction. So the conduction or electricity due to only majority carriers like P and N regions. P region has majority charge carriers, holes. N region has minority charge carriers or electrons. Due to this majority charge carriers, holes and electrons, the electricity is conduct. On the other hand, positive and negative ions are immobile charges and therefore do not take part in the conduction. It may be noted that no external voltage has been connected to the PN junction. As shown as the PN junction is formed the following process takes place. The PN junction is formed the following process. First point, free electrons diffuse from N region to P region. When electrons diffuse from N region to P region, that is nothing but movements or motion of electron. And second one, holes diffuse from P region to N region. Third one, diffusion process takes place across the junction because there is a difference in the concentration of charge carriers on both sides of junction. That is, in N region electrons are more in number, whereas in P region holes are more in number. Exactly. Previously I told previous same as it is. Since the mobility of electrons is greater than holes, the electrons will cross the PN junction first and enter into the P region. As a result of this, electron-hole recombination takes place in the P region, leaving negative ions on P side and positive ions on N side. This situation is shown in figure above. Now let us once again, in N region, the concentration of charge carriers on both sides of junction. In N region, the electrons are more in number, whereas in P region, holes are more in number. Since the mobility of electrons is greater than holes, the electron will cross the PN junction first and enter into the P region. As a result of this, electron-hole recombination take place in the P region, leaving negative ions on P side and positive ions on N side. This situation is clearly shown in above first figure. And coming to the fifth point, the region containing the uncompensated acceptor and donor ions is called depletion region. The region adjacent to the PN junction which is depleted of majority charge carriers is called depletion region or transition region. The region adjacent to the PN junction, which is depleted of majority charge carriers, is called depletion region or transition region. Since this region has immobile or fixed ions which are electrically charged, it is also known as space charge region. Moreover, as the immobile ions within the depletion region exist in the form of parallel arrows, it is known as depletion layer. The thickness of the depletion layer is usually of the order of 1 micron. 1 micron, that means 10 to the power of minus 6 meter for 5 mm size crystal. Since the depletion region contains no mobile charge carriers, it behaves like an insulator. It behaves like an insulator. Because of the positive ions on N side and negative ions on P side, an electric potential is established across the junction. This potential is known as barrier potential, denoted by V. At room temperature, V is about 0.3 volts for germanium and 0.7 volts for silicon. At room temperature, V is about 0.3 volts for germanium and 0.7 volts for silicon. The barrier potential can be decreased or increased by applying external voltage. Next, the diffusion process continues till the barrier potential is developed. The diffusion process continues till the barrier potential is developed at the junction. This barrier potential opposes the flow of majority charge carriers for one side to the other side. That is, the electrons in N region are prevented from across the junction by the attractive force due to the net positive charge of its own section, and also by the repulsive force due to the net negative charge of the P region. In a similar manner, the holes in P region are prevented from crossing the junction, and it helps the minority charge carriers to drift across the PN junction. The minority carriers are constantly generated due to the thermal energy. The minority carriers are constantly generated due to the thermal energy. Next point, 10th point. The current produced due to the diffusion of majority carriers is called majority carrier current, and then the current. Next, circuit symbol for a junction diode. When a p-type material is suitable joined to N-type material, the contact surface is known as PN junction. The total unit is called PN junction diode or semiconductor diode or crystal diode or simply diode. Once again, when a p-type material is suitably joined to N-type material, the contact surface is known as PN junction. The total unit is called PN junction diode or semiconductor diode or crystal diode or simply diode. A PN junction is known as semiconductor or crystal diode. That is shown in figure below. The representation of PN junction diode and its circuit symbol shown in below. Now you can see this figure, these two figures. Are you seeing this figure? First one is PN junction diode or crystal diode, and second one is circuit symbol of PN junction diode. In the circuit symbol, the arrow mark indicates the direction of the conventional current in the diode, that is from P type to N type. The metal contact taken outside from the p-type material is called anode. The metal contact take out from the p-type material is called anode, and the metal contact take out from the n-type material is called cathode. It is denoted letter K, anode denoted letter A. Now coming to the figure, the circuit symbol of the diode is this figure. Left side, its indicated letter is A, it's an anode terminal. Right side, that is indicated letter K, that is cathode. So diode has two terminals, anode, cathode. So arrowhead is towards cathode. It indicates the direction of conventional current in the diode, that is from P type to N type. A diode is a unilateral device because the conduction takes place in only one direction, that is from anode to cathode. Diode is a unilateral device because the conduction takes place in only one direction, that is from anode to cathode. A diode is an example for bipolar device because the current within the PN junction is the sum of electron current, that is in the N region, and hole current in the P region. The important questions are frequently asked questions of in this period is, first one, explain the formation of PN junction diode, and second question is, draw the circuit of PN junction diode. Draw the circuit of PN junction diode. So up to this, upon this completion of this topic, the student will be able to know or understand the topic, the formation of PN junction diode. Thank you.